Welcome back to the Health Longevity Secrets Show with your host, Dr. Robert Lufkin. And for some of our non-English speaking listeners,
ホストのロバート・ラフキン博士と一緒にロンゲビティヘルスへようこそ。何語か理解できる場合はコメントに書いてください。
and now, please enjoy this week's episode.
Today, we get to unlock the secrets of supercharging every cell in your body with our captivating discussion of the unsung heroes of biology, mitochondria. Renowned experts like Dr. Monisha Banud, advocate for the cellular health optimization and author of The Anatomy of Well-Being, alongside Sarah Turner, a red light therapy enthusiast, and Dr. Hemal Patel from UC San Diego, join us to illuminate the wonders of mitochondrial function and the innovative therapies on the horizon. We delve into how red light therapy can enhance energy production and the critical roles of nutrition and fundamental health practices for mitochondrial health. This episode is a pre-recorded segment from the Biohacker Expo that recently took place in Miami. It was attended by all sorts of luminaries, including William Shatner, who at 92 looked great. Whatever he's doing for longevity, I want to do too. So for mitochondria, have we ever considered the profound connection between like gut microbiome and mitochondria? Well, in this discussion, prepare to be fascinated as we uncover the complex communication network that these cellular powerhouses share with our microbiome, affecting everything from our mood to our longevity. We reveal groundbreaking research on biophotonics, the potential for mitochondrial transfer to treat heart conditions. Our exploration doesn't stop here. We also navigate the promising fields of quantum biology and the careful approach to supplements for nurturing these critical organelles. Rounding off the journey, we venture into the advanced realm of mitochondrial health testing, comparing traditional methods with cutting-edge functional tests for a more comprehensive understanding of our body's inner workings. And now, before we do that, I'd love to share one more piece, which is a short 2-minute trailer that's an introduction of an hour-long television show I did on Epic Times. I was featured on American Thought Leaders with the great John Yakelik. Had a lot of fun doing it. This is the trailer. You can watch the full episode if you want. We'll have a link to the show notes. It's also available online for free. There are biases built into our institution. In other words, I'm a doctor in a clinic, right? I have a diabetic patient. I get to spend 7 minutes with them. It's much easier to prescribe metformin and insulin and take a couple lab tests than it is to do an entire program about low carbohydrate diet and switch over their whole eating structure.
Dr. Robert Lufkin was once a self-described product of the medical establishment with a fruitful career as a professor of medicine. He's published hundreds of scientific papers and has received millions of dollars in government funding. But when he was diagnosed with 4 seemingly unrelated chronic diseases and told he'd be on medication for life, he started looking elsewhere for answers.
It was through lifestyle changes that I was able to reverse these very serious and potentially fatal diseases and get off all medications for them.
Lufkin is the author of Lies I Taught in Medical School and the Truths That Can Save Your Life. This is American Thought Leaders, and I'm Jan Yakelik. Don't forget to subscribe to our Alerts newsletter, and you'll never miss an episode.
This episode is brought to you by L Nutra, maker of the Prolong fasting mimicking diet. If you'd like to try it, use the link in the show notes for 20% off. And now, please enjoy this week's episode. Good afternoon, everyone. I'd like to welcome everyone to the Mitochondria session. Is that the title of it? I think it is, yeah. My name is Rob Lufkin, and I'll be hosting this session. My background is as a radiologist. I've gotten interested in the longevity space, but I'm especially excited about mitochondria because of the role they play in metabolism, which is at the root, in my opinion, of all the chronic diseases that we face, as well as aging and longevity itself. So I couldn't be more excited about this. My favorite book on mitochondria is Power, Sex, and Suicide by Nick Lane, which is a great book for the lay audience. The only problem is the title. When I was reading it, my wife would hide the book so my children wouldn't see it because she thought it was salacious or something. But it's a great book. Now I'm going to invite the rest of the speakers to introduce themselves and also share if they have a favorite book on mitochondria for the lay audience that we could read. Anyway, Monisha, yeah.
Yeah, hello everyone. My name is Dr. Monisha Binoud. I am a quintuple board certified medical doctor, which means I have 5 specialties on how the human body works. I am based in Florida, and I'm going to toot my own horn here. My favorite book is my book on the anatomy of well-being, which really explains not just mitochondria, but cellular health for the layman and how to really optimize each and every cell in your body, including your tissues, organs, and functionality of everything.
Thank you. So I'm Sarah Turner, and the main reason that I'm into mitochondria is because I have a red light therapy company, and of course the main target for red light is the mitochondria. I also love the Nick Lane book. Both his books, actually. He's written a couple of books that are really fascinating on the cell. So, yeah, that would be my recommendation.
What's his other one called other than Sex, Lies? I mean, Sex, Lies, and Videotape. No, Sex, Power,
Suicide.
Sex, and Suicide. Yeah, what was the other title? Do you remember?
The other one is, oh my goodness, New Energy or something?
Oh. Yeah,
Yeah.
check it out. Yeah,
Yeah,
Nick Lane,
super
just Google it.
Yeah, Doug Wallace, also super cool. Yeah, there's some fabulous stuff.
My name is Hemal Patel. I'm a faculty member, professor, and vice chair of research in the Department of Anesthesiology at the University of California, San Diego. And then my corporate hat, I'm also the chief scientific officer for Versea Discovery. And we've been looking at mitochondria for decades in my lab, and we now have a commercial test that we're launching where you can actually measure your mitochondrial function and structure.
Yeah, exciting stuff. Well, I'll start off. When I went to medical school, we were taught that the nucleus of the cell was the brain of the cell, and that the mitochondria were sort of the batteries or the powerhouse of the cell. But all that's changing. So maybe we'll start with the first question for anybody on the panel. What are mitochondria, and what is their function? Anybody?
All right, so I'll do my little demo for you guys. So yes, this is a mitochondrial panel, but I really want you to understand the human cell because there's more than just mitochondria. In order to get your mitochondria to work optimally, think of your cell, no pun intended, as a cell phone, right? So when we all have our cell phones, we're holding it, we're taking care of it, we're doing a number of things. Your cell phone case is essentially your cell membrane on each cell, and you want that to be optimal so when the mitochondria need to create energy and do the things they need to do, that's working. So yes, you have your nucleus, you have your mitochondria, and mitochondria are the organelles inside the cells in addition to Golgi apparatus and a number of other organelles that produce energy, ATP, for the body with oxygen and the food you eat.
I love the origin story of mitochondria. Maybe one of you would share that with us, how they came to be part of our bodies.
Yeah, so when organisms evolved, right, essentially life started with a single cell. And no one really knows how that origin story actually evolved, but there was the rudimentary cell probably had a very basic membrane structure and organelles, and it was nucleic material that allowed that cell to divide. As that cell started to organize into multicellular organisms, we needed energy to create that force that would drive that multicellular phenotype. So what these cells started to do, and there's an endosymbiotic theory that is out there that suggests this, is they incorporated organisms that provided that energy. And so mitochondria are old bacteria that got incorporated into human cells, eukaryotic cells. And chloroplasts are the opposite of what got incorporated into plants and gave them that ability to harness energy through light. And so essentially it's organisms living inside us that allow us to do everything that we do.
Yeah, that's a great story. When I went to medical school, we learned about a few very rare diseases that were caused by mitochondrial defects. Today, though, that thinking has changed a lot, and I think we're hearing at this conference, and it's becoming self-evident that mitochondria are at the root of so many diseases. So, what is the relevance of mitochondria to health and disease?
Well, I think one way to think about mitochondria is as the sensor in the cell, as an environmental sensor. Because we now know that the mitochondria can transmit information to the cellular DNA, can activate certain proteins, and we now know that the mitochondria is one of the main receivers for external information like light, for example. That we're electric beings, you know, we're all about electron transfer, and this is something that also happens within the mitochondria. So I think thinking of the mitochondria more as a sensor, perhaps, in the cell is a more useful way of thinking than just a battery in the cell.
So, yeah, absolutely, because there's electron transport that's happening and the communication within the mitochondria and the cell itself. But what we are seeing, aside from genetic mitochondrial diseases, is the non-genetic component of mitochondrial disease, which essentially is every chronic disease that people are experiencing, all the way up to cancer. So whether that is obesity, high blood pressure, cardiovascular disease, any disease in the body has mitochondria to produce its energy, and when that cell becomes dysfunctional, it's not. And there's a number of factors that contribute to it. We have testing here, we have one of the tools here, and then I have tools that I use. So I think we've got a great spectrum to talk about each and every component of how we can address this dysfunction.
Yeah. And the genetics of it is kind of interesting, right? So you inherit all of your mitochondria from your mother, but then you inherit your genome, your nuclear genes, partly 50% from your mom, 50% from your dad. And so with diseases, you could have the most perfect mitochondria that come from your mother, but if your dad gives you a bad bag of genes, and a lot of the genes will then encode into the mitochondria. So the mitochondria only make 37 genes on their circular DNA. 13 of them are critical to this electron transport chain. The rest of the hundreds of proteins that drive mitochondrial function come from your nucleus, and the genes that come out of that and the proteins that get made. And so there is this new balance of thinking about mitochondrial disease as not just mitochondria, but there's a nuclear component to it as well.
And for all of you out in the audience, after we do a few more questions here, we're going to open it up to any of you out there. If you have questions, hold on to them, and we can address them to the panel. One interesting thing when we're looking at structures in the body or things in the body is to consider the difference between structure and function in a mitochondria, and what are the consequences of that?
Yeah, so I've been enamored with the heart for years. I did my PhD on how to protect the heart from ischemic injury. And one of the first amazing striking images was to look at a light level of a cardiac myocyte. It is this crazy looking boxcar-like cell. You can see all the structures on it. When you look at it under the electron microscope, which is thousands of X magnification, you can actually see mitochondria and their convoluted turns and twists in their cristae. It turns out that the heart actually has 3 different types of mitochondria. They're not all created equal within the cell. There's mitochondria that sit at the cell surface, and these are sensors, right? They basically sense the external environment, and they signal. They tell the cell what to do, how to interpret that external environment. They have these mitochondria called the interfibrillary mitochondria that sit inside that muscle, and the entire job of these mitochondria is to make energy. They make a boatload of energy. Elon Musk hasn't gotten involved in this, but mitochondria basically you make ATP and you use it. There's no storage system in your body to store that energy, so there's no battery to do this. The heart in a day makes kilograms of ATP, but you don't go up and down in weight by kilograms because as soon as it's made, it's used. The third population of mitochondria in the heart are perinuclear mitochondria. They sit around the nucleus, And the new evidence suggests that these may be the major drivers of mitophagy within the myocardium. And so as your heart evolves and beats and continues and grows chronologically with age, it's the mitophagy phenotype that gets rid of dysfunctional mitochondria. So even though mitochondria make energy, there's so many different diverse aspects of this within a single cell as well.
Yeah, there's an interesting story about white meat versus dark meat in chickens or in any kind of birds. Somebody want to comment on that vis-a-vis mitochondria? The origin of that?
So, I mean, brown fat versus white fat, right? Yeah. So the idea is that white fat has a lower content of mitochondria and it looks white. People like me have omental fat around their bellies, which is what drives a lot of diseases. Their mitochondria are inefficient. They're not really making energy and it's just sort of storing sugars and other things in a different form. Brown fat, which a lot of organisms have on the back of their neck, the reason it's called brown fat is because it looks brown, and it looks brown because they are packed with mitochondria. What these mitochondria do is they uncouple and they generate heat, and so they create this higher metabolic state. So a lot of these therapies that you would do with cold plunge, heat stress, they're designed to make more brown fat in your body, and so they drive this. And so by organ level stuff, if you look at a heart, it looks red, right? And it's red because there's a ton of mitochondria. 30% of the volume of the heart is mitochondria, and so they're chock full.
Well, throughout this conference, we're seeing, if you walk out in that room, you see a lot of red lights all over. And what's with that? What's the effect of red lights on mitochondria? What's going on there?
Well, red light is received by the mitochondria. So there are lots of theories of how red light is working, but the predominant one is that it's received by an enzyme on the respiratory chain in the mitochondria. So we have this respiratory chain where we have electrons that are passed down a train, and eventually that leads to the production of ATP. And one of those enzymes, cytochrome C oxidase, becomes excited by red and near, well, depending on how deep the light's penetrating into the body, red and near infrared light. So it excites that enzyme, and that causes a cascade of reactions which leads to more ATP and a dissociation of nitric oxide. So that's why it's so interesting in red light therapy, because that seems to be one of the main mechanisms of action. And obviously this is hugely important for areas like the brain where we have a lot of mitochondria. You know, anywhere that's mitochondrial dense, you know, as we were talking about, that's where red light therapy is going to have a big effect. So I think that's why everybody, you know, red light is such a brilliant therapy, because it is working on the mitochondria. It is helping the body produce energy. If you have energy, you can do a lot more healing. So that's why red light's kind of seeing a bit of a panacea, that it heals everything, but that's because you're dealing with the root cause, which is insufficiency of energy, which you get from the mitochondria.
So if we're using red light therapy to energize our mitochondria, what is the depth of penetration of that wavelength of red light? I mean, should we expect it to go through our whole body, or is it mainly just hitting our skin, or
it depends on the wavelength.
Yeah.
It depends on the wavelength of the light, because as a rule of thumb, the longer the wavelength, the deeper the penetration. However, you know, up to a certain point, because water does become a chromophore too at a certain wavelength. Mm-hmm. So like over 900 nanometers, you start to see water's absorption increase. So you may see a drop-off in the depth of penetration because the light becomes absorbed by the water. But certainly for things like brain, you know, heart, things like that, where you need to get deep in the body, you need long wave light, which is in the near infrared range. So, you know, usually you'll see people using between 850 and 1200 nanometer light for deep penetration. To get to the skin, you can use red light, which is around about 630 nanometers.
So thinking of the electromagnetic spectrum, and you have the red light, and then, as you said, the infrared, yep, and then heat and all, are there beneficial effects to the mitochondria from heat therapy, like a sauna, that sort of thing, in that wavelength of light? Is there something there going on?
Well, when you get into heat, when you get into these saunas, usually you're very long wave, like 3,000 nanometers. And then it is a different biological effect. You're talking more about heat shock proteins. You're talking about thermal energy. So red light, photobiomodulation, tends to be at a shorter wavelength because you want a photonic effect, specifically on that mitochondrial enzyme. So yes, it's a different effect. Oh, brilliant effect for the body. Sauna is also good, but it's not a photonic effect.
So we have the red light therapy. What other things can we do to improve our mitochondrial function? I mean, are there supplements or what types of things? Lifestyle? What works on mitochondria?
So, I'll handle a little bit of that. But the first thing I want you guys to understand, when it comes to mitochondria, there's multiple processes that are going on. None of this is happening in isolation. So your mitochondria can be at the same time going through fusion, fission, mitophagy, and this is a continuous process in the body. So what I mean by that is fusion is really taking some of the mitochondrial parts that have been damaged and coming together so the mitochondria can work, right? And then we have the development of new mitochondria. So things like infrared saunas and light can create more mitochondria. And then you have mitophagy, which is really the clearing of this damaged mitochondria that cannot be used at all in the body. And besides the tools and techniques, which are the physical ones like light and water, we can also do nutrition and supplementation. So for me, I'm looking at what are the ingredients needed for these cellular processes to happen. And a lot of them are antioxidants, because what happens is, each of these cells that you have, they're getting exposed with the free radical damage and having oxidative stress on a daily basis. So when I'm testing my patients, they have very high oxidative stress levels. And how do we fight oxidative stress? Antioxidants. Where do you get antioxidants from? Certain vitamins like A, C, and E, also from alpha lipoic acid, things like CoQ10. So those are things that can be supplemented, especially when I'm thinking about individuals with high cholesterol and they're on Lipitor and they lower their CoQ10. By doing that, taking the Lipitor, they're actually causing their mitochondria to be even worse off. So when you're looking at your body in this whole holistic perspective, you want to look at how are you fueling it, not just from an external environment of these great biohacks that are available, but how are you doing it internally?
I mean, the three things to do would eat, sleep, and move, right? I mean, but it's so hard to do. And so people are trying to hack their way to eating, sleeping, and moving to not do those things. Some of the things we've been playing around with in the lab, we have a huge collaborative with Sachin Panda, who's at the Salk, who essentially popularized this idea of intermittent fasting. And so intermittent fasting will change your mitochondrial biology. And it's a fairly easy fast that we have our subjects do. It's a 10-hour eating window and a 14-hour resting window. It takes about 3 months to completely change your mitochondrial biology at that state, and it's a global phenotype. We're doing studies right now with Joe Dispenza, where in 7 days after you go into this meditative space, your mitochondria behave completely differently, but you're changing your gut, your metabolites, you're secreting lots of different things at these stages, and so you can get that. And then we're trying to push the extreme. So we're doing some studies with a couple groups where we're looking at ayahuasca and some things that everyone's into now. And ayahuasca will change your mitochondrial biology in 48 hours. But the problem is there's no way to maintain it, right, unless you keep doing these hits. And so this is this idea of a lifestyle change that's maintainable to drive your mitochondria in a consistent manner. And I think everyone's after that.
I would just add, one of the things that I've started experimenting with, and I know a lot of biohackers are already on it, is things like methylene blue and breath work as something that you can use alongside particularly red light therapy, because methylene blue is actually it's an electron recycler, so it kind of donates and receives electrons kind of depending what mode it's in. So that's a good supplement to kind of use alongside some of these other things. And of course breath work, the more you can bring oxygen into the system, the more efficient the mitochondria are going to function.
So we've established that mitochondria are useful. They play an important role in chronic diseases and are foundational in our metabolism and affecting longevity and aging. So now we use different approaches with red light therapy or CoQ10 or C60 or methylene blue or ashwagandha, or ayahuasca, and we did all sorts of different approaches to improve our mitochondrial function. Now the question is, how do I evaluate my mitochondria? What are your favorite ways of checking what things are working, or what are the things we can look at that give us feedback that our mitochondria are healthy and that I've taken enough ayahuasca this week?
I think the simplest thing is to really look at your energy level, right? Are you fatigued, right? When you wake up in the morning, where is your energy at? Obviously there's a spectrum from, just being tired to chronic fatigue. And we're finding now a lot of patients with chronic diseases have chronic fatigue. So it's just a continuous interplay here of what is going on in the body on this cellular level. So really paying attention to in the morning, how you wake up and what do you need today? Like, are you just minimally fatigued? Are you not? Do you need to sit with some photomodulation? Do you need more nutrients? And then really working with practitioners at that clinical level to do this in-depth testing to see, are your mitochondria dysfunctional? Because I do that on a daily basis with my patients, and it takes time to repair. I know you're saying that some of this can be repaired in the matter of a week, but when people are dealing with chronic illnesses, it takes time to reverse that disease. So the best medicine is prevention, and start taking care of it now.
We've been developing mitochondrial ways to measure mitochondrial function structure for decades in the lab. We're involved in a number of clinical studies where the gold standard is a muscle biopsy, right? It's this gigantic needle. You go in, they numb your leg up, stick that needle in, pull out the muscle, comes to my lab. We then spend the next 6 hours excruciatingly analyzing whether it's using fat, glucose, this, that, the entire electron transport chain. So a couple years ago, I was involved in the NASA twin study where they put a twin up in space for a year and his counterpart stayed on Earth. And we had blood samples from them all throughout before the flight, the year-long flight, and then after flight. And NASA sent us a bunch of blood samples and said, this is all we can give you. Tell us where the stress is in their system. And so we invented a test, right? So we basically hypothesized that the environment that astronaut was creating up in space by all of his exposure was captured in his blood sample, and we could transfer that environment to a cell that's never seen this and measure mitochondrial function in that cell. So rather than getting his tissues, we could basically pattern cells that represent every organ of the body and use his blood as the surrogate for what's happening. We were able to predict crazy toxic functions in muscle, immune cells, and other systems, and those were the systems that were compromised in the guy in space, and he recovered at a decent time. And so now we're actually doing this, right? So you can actually take a blood sample, and from that blood sample, we can run the exact same profiles we're running. And we can tell you whether the mitochondria are respiring, if they're dysfunctional, if there's structural defects, and it gives you a real readout of testing some of these therapies on yourself, right? And the idea, and I think where people are moving, is they want to put the power in their own hands of knowing how their biology is, and tests like this give them that advantage.
In that test you developed in your lab, but as I understand, it may be commercially available to consumers at some point as well, so that we could get access to it. Perhaps.
We're working primarily with providers right now and research groups to then really take in some data. There's a huge machine learning AI algorithm that goes along with this test. So not only are we doing the testing, but we're asking them to tell us all about what the therapies they're on, their ages, their sex, their physical, mental, emotional well-being. And so as the more and more people adopt this test, the system gets smarter and smarter about predicting how to help everyone, right, at the end of the day.
Well, we're certainly undergoing a revolution in our understanding of mitochondria, what their purpose is, what their function is, and just everything about them. I would like to ask the panel, what in the last 5 or 10 years were your big aha moments in the understanding of mitochondria? How have your thoughts changed? What are the big breakthroughs you think that we've experienced recently on these?
So I've been thinking about this for the last couple months. I've met a lot of people that been talking about this me screen test too. And I was in New York a couple weeks ago and we had this intense conversation about the socialization of humans as well as organ systems. So we think about us. We are built to live in a society. When we thrive is when we have good friends and interactors. If you look at all the blue zones, the common factor in all the blue zones is people have lived together and there's multi-generational homes that they live in, right? As soon as you separate that individual from that collective, they go into isolation, depression, anxiety, all of these things creep up, and that system declines. If you look at mitochondria, most people have ignored the fact that they're actually a networked organism that lives in every one of your cells. So not only do they make energy, but they talk to each other. And I think the revolution is looking at that network connectivity. And the importance of that, I think, is just starting to be studied. And I think it could have major implications. If you look at a lot of diseases, they are when mitochondria become isolated in a cell system and they lead to untoward effects that then lead to free radicals and other things. When they're connected, they support each other, just like humans do as well, and you get that support system. So I think biology has a lot of this imprinting that we see in the social world, and we can learn a lot from biology. We can also take a lot of that social dynamic and apply it to biology as well.
In those communications with the mitochondria, are those primarily chemical, or is there an electromagnetic component to those?
Yeah, so there's an electromagnetic component, so they have sort of electrical potential that they tie to, and they become the largest sink for calcium in your body, right? They store and use that calcium, but they keep it sort of inactive in the rest of the cell as well.
Is there evidence that this communication extends outside the organism to other organisms in close physical contact?
I mean, the postulation's there, right? That this is a way that all the cells in your body are communicating with each other because they share this. The other aspect that we've started thinking about, we do a lot of microbiome work in the lab as well. And your gut is probably about 100 trillion bacteria. And if you're bacteria, who are you going to talk to? The bacteria that we incorporated 1 billion years into our cells, right? So it's likely that the gut is speaking to all of your mitochondria as a way to balance that system.
And leading on from that, I think one of my revelations was I did some work a very long time ago with Fritz Albert Popp, who was looking at biophotonic emission. And so mitochondria do actually emit light. As well as receiving light, they emit light. And this could be one of the ways that you have this communication, which is hugely important in the brain and very interesting because we don't know how red light has an effect on deep brain structures because people seem to get recovery from things like Parkinson's, which we know is right deep in the brain. So that's one of the very interesting things, that it could be this communication with biophotonics, and that goes back to the antioxidants and to these reactive oxygen species that are produced in the mitochondria. That could also be part of the communication. So it's kind of a double-edged sword with these reactive oxygen species, whether they're good or bad. Some of it could actually be a communication, and some of it could be a byproduct. And I think recently we've discovered that some mitochondria are free-floating in the blood. Now, that was a huge thing that I was certainly never taught when I was learning biology. You know, we think that mitochondria are contained within the cell. But as soon as, we had this knowledge, okay, they can actually migrate, they can actually move, they're actually very dynamic. I think that's a huge revelation in biology, that mitochondria are not always contained in the cell. They can actually migrate to areas where they're needed. So I think that was really as late as 2019. Yeah.
Yeah, there have been so many breakthroughs in our understanding of mitochondria. I guess the next question is, what are the remaining questions? What would you like to know in the next 5 years? What are the big question marks about mitochondria that we need to answer going forward?
Yeah, so to continue on with what you started with, what I've seen with my patients is, because I do a lot of gut testing, that's primarily my focus is gut health and longevity, is that when we do address communicating with the microbiome and really make a more beneficial microbiome in them, their mitochondrial function is testable, and I see it change. So that to me is really where I think, we influence our microbiome on a daily basis with what we do. With every next meal, you are changing your microbiome, and it's your choice to change it in a beneficial way to you or not. And I think for me, that's going to be the biggest thing, is really to solidify that research with the microbiome and the mitochondria and oxidative stress, and see that, because I've spent years looking at individual cells as a pathologist, cytopathologist under the microscope. And, for me, all these cells are angry, and you can't see mitochondria on a normal microscope. You have to look under an electron microscope. But you can see that the cellular structures are changing, where the cells are dysplastic or dysfunctional, and then that's when they're not able to do the things that they need to do. And this is a daily process when individuals go in and out of the hospital getting biopsies. This is a process of every disease. So I'm looking forward to seeing how we can actually prevent and reverse disease by addressing the microbiome first, and then it applies to every single disease.
There's some new data coming out. I've seen it in early papers and a couple grants and things. And this idea of a mitochondrial transfer, which sort of goes off of what you were saying. So you can actually isolate mitochondria from organs that will reproduce, like your skeletal muscle. And the studies that were done, I think they were Australia-based, but they took people who had heart failure, and they purified mitochondria from their muscle, and they injected it into their heart tissue, and they saw dramatic resolution of heart failure phenotype. So I think the next revolution, instead of stem cells and exosomes, is going to be mitochondrial transfer, right? Taking mitochondria from young systems and putting it into old systems and making them look younger. It's coming.
Interesting, very exciting. Before we open up to questions from you all out there, are there any other points that any of you would like to make that we haven't covered yet?
My only thing was going to be on like future technology is introducing this, the whole field of quantum biology, because we've already talked about chloroplasts and how that works in plants and how that's kind of like a mirror for what's going on in our mitochondria. And we already know now that that's probably some kind of quantum process. How we have this huge efficiency in energy production in the human, and we don't entirely understand how that works. But when you start to bring in some of the quantum theories, electron tunneling, there's all this very interesting biology that I think isn't fully explored right now, and I think that's going to be something very exciting for the future.
Specifically the electron transport
specifically
chain,
how
right?
how we get that kind of level of efficiency in the body. I don't think it's correctly understood by our current understanding of these processes. But like I say, we already can see it now in things like photosynthesis. That's now becoming much more widely recognized that there is certainly quantum processes going on there. We just haven't quite made that shift over to human biology.
And there's one caution I do want you to be aware of, is that supplementation can be great, but supplementation also can have the opposite effect if you use it incorrectly. So specifically NADH, which is another supplement that can be beneficial for mitochondria, it's great in low doses, but when you overdo it, it can actually negate the benefit of it. So work with a practitioner to actually help you so you're doing the right thing for your body, as opposed to creating more problems.
Are there any standard doses that, without giving medical advice, but are there any guardrails we can suggest to this audience?
No. Targeted supplementation is the way to go. Get your blood work tested. If you are not deficient in CoQ10 or alpha lipoic acid, you don't need it. You're just going to cause more harm than good. So test. Yeah.
Are there any other supplements we should watch out as far as interfering with mitochondrial function?
I think medications more so is the biggest concern, is whether that is a over-the-counter pain medication or that is, anxiety medication or heart medication. Just really look at the interactions, because each and every medication you take comes with a side effect.
And is there any common structural or functional aspect to the medications that interfere with mitochondria, or is it just on a case-by-case basis? In other words, is a certain class of pharmaceuticals we should be especially cautious of, or is it just...
Statins is definitely one, yes, because that will influence your ubiquinol, so coenzyme Q.
A lot of chemotherapy agents do it as well. They're completely drive your antioxidant system to the ground.
Which a lot of these medications, by the way, especially chemotherapy, destroy your gut, right? So now we go back to fixing the microbiome. So medications, whether they are anti-inflammatory, high-dose steroids, or chemotherapy, even hormonal therapies can destroy your gut. And marijuana in high doses can also destroy your gut, but in not so high doses can actually fix the microbiome. So this is where that very delicate balance in our ecosystem is important.
And which hormonal therapies interfere with the gut microbiome, or is it across the board at high dose in all of them?
Across the board, depending on which health issues you're dealing with, to be concerned about.
I think one of the things is everyone has a precision system in their body, right? And it's energy driven. And so unless you know what your system is doing at a particular state, you can't really provide a therapy. And so that's, I think, the baseline aspect is know your foundational mitochondrial functionality, your gut functionality, and then go in and try to come up with a personalized approach to treating that.
Great. Well, if anyone has any questions, come on up to the microphone there, and look forward to hearing what you have to say.
Thank you all. Fantastic information. I had a follow-up question on what you referenced with regard to ayahuasca being able to change the mitochondrial makeup within 48 hours rather than three months, I think you said, with fasting. Are there any similar studies with regard to any other psychedelics or plant medicines like psilocybin, MDMA,
Yeah,
iboga?
psilocybin's been tough. There is a center on campus now for psychedelic research, so we're starting to get some samples in from those individuals. The FDA regulates it quite tightly. I have a collaboration with Promega as well. And so Promega is a privately owned life sciences company, and their CEO had some interaction, either a friend or something, and he actually built a psychedelic center on his campus called Eusomnia. And so they're testing for the FDA all these compounds and things, so we're hoping to get some samples, but it'd be amazing to see.
I have a question about a test called MitoSwab. I don't know, I had it done 2 years ago. It's a mitochondrial buccal swab.
Yep.
And I had it done, and then none of the doctors I work with actually were familiar with it or knew how to interpret the results, or I just was wondering if you had thought about it, and I just wanted to share my results and ask if it was very unusual that I had 37% of the complex 1 and then over 100 on the remaining 3. And is this something, that you would see, like maybe other parts compensating for part of the chain not working well, or what do you think about this test in general?
Yeah, so this has been one of the only commercial available tests to measure mitochondrial function. It's based on that cheek scrape, like you said. You ship the sample to them on ice because the cells have to be alive. So the minute a cell leaves the body and you give it time, the cells start degrading, right? And so the functionality is really a condition of how quickly it gets to their company, and they measure the assay. The assay is based on a colorimetric assay that looks at enzyme function. So each of your complexes has specific combinations of proteins that create enzymatic function. And so they're looking at enzyme components of complex 1, 2, 3 to tell you what your mitochondria are doing. The way I've described it is it's like if you go to a mechanic, the mechanic can open the hood and then you tie his hands behind his back and he can look around, and he's got to figure out what's wrong with the car by doing that. We've sort of advanced to the next level, and it's really more sophisticated testing that we've been developing in the lab. So what our test allows that mechanic to do is untie their hands. They can actually go sit in the car, turn that engine on, and take that engine car for a drive, right? So the mechanic's going to be able to tell a lot more about your mitochondrial health by looking at the function and structure in a really sort of live physiological setting than to look at dead enzyme function kind of thing. So it'd be interesting to see the result. And we've talked to a couple practitioners that they have the same question, right? Why should we adopt your test when we're doing the mito swab? And for a lot of them, it's been a random number generator, right? They'll basically get a value and then they'll do it again and it'll be a completely different value that they get within a very short amount of time. And so this is where I think the void in this space has been, is people really target mitochondrial health, but there's been no way to really test this at a deep functional state. And we think that studies like ours and tests like ours, the Me screen, fill that void.
Hey, Herbert. Thank you. Very informative. Question about the testing. What are some of the tests you think are a must-have for anyone here? And it's probably not a one-fits-all. There's a gut microbiome that's very important. There's your test that I've never heard about that seems very interesting as well. But would you recommend a series of tests? And I don't know if you know the cost of it, or how people can actually really test themselves in a series of tests that will give them a proper reading and baseline.
Yeah, so absolutely, great question on testing yourself. So just to give you an example of myself, so every December I do my full panel of tests. I already have my baseline genetic markers. Genetics is not going to change, but then the actionable stuff. So really looking at your gut microbiome. You can also now do testing not just on the gut microbiome to see if you have issues with dysbiosis, inflammation, maldigestion, pathogenic organisms, but what are your microbiota capable of doing? So there's genetics tests on your microbiota that live within you. And those can tell you whether or not you are capable of metabolizing protein. So maybe you shouldn't be on a high protein diet, whether or not they contribute to cardiovascular disease, whether or not they contribute to neurologic disease. So really getting more deep into the microbiome. You can also then, I recommend, making sure you have a great nutrient panel, looking at your antioxidants, vitamins, minerals, toxins, heavy metals. I'm a practitioner here in Florida, and I have a lot of patients who love eating out, and they're like, I'm eating at very nice restaurants, but guess what? They have heavy metal toxicity, especially mercury levels are really high, so much so that the Florida Department of Health is always calling me and asking me, what are these people doing? So those, I would say, are your two baseline. And then depending on your age and your health issues, and if you're focused more on prevention, also looking at your hormonal balance, because you got to remember at the end of the day, your body, your microbiome, everything you do is creating hormones, neurotransmitters. So in order to have the full functionality, these are your baseline tests. And I've been a medical director at many laboratories, LabCorp, Quest, all these kinds of places. These are not the tests that you go there for. Those tests are in isolation at that one moment when you are walking in and they're demonstrating that. This is where we want to look at the testing of your actual functionality of how are these chemical processes and cycles going on in the body.
And so where do you go for that?
You can come to me.
I want to thank all our panelists for coming today, and also thank all of you for listening. I think the panelists may be available off stage if you have further questions, but we're going to clear the stage for the next. What? Okay, yes. Yeah, you're going to.
Yeah, so I'm also doing a book signing at the book signing booth after this if you want to come chat with me.
Thank you.
If you are enjoying this program, please hit that subscribe button, or even better, leave a review. Your support makes it possible for us to create the quality programming that we're continually striving for.
Can I start? Is it recording?
It's already recording.
Oh, sorry. This is for general information and educational purposes only, and it's not intended to constitute or substitute for medical advice or counseling. The practice of medicine or the provision of healthcare, diagnosis, or treatment, or the creation of a physician-patient or clinical relationship. The use of this information is at their own user's risk. If you find this to Beyond the Value, please hit that like button to subscribe to support the work that we do on this channel. And we take your suggestions and advice very seriously, so please let us know what you'd like to see on this channel. Thanks for watching, and we hope to see you next time. You should say that.
That's good. You need to say that. That's really good. You like it? You want to do one more time, or is that good? I think that was good.
You need to save the recording.
Very good.